So far we've learned how to reduce rational expressions, multiply and divide rational expressions, and of course now it's time to add and subtract rational expressions. So we need to go back and review on how to add fractions. Adding is very different than multiplying and dividing. In order to add fractions, you have to have the same denominator. You keep the denominator and you add the numerators. Then you can see, could you reduce it? And you can. Subtraction, the same thing. You must have the same denominator. You keep the denominator and then you subtract the numerator. And then and only then at the last you ask yourself, can you reduce it? And you can. So again, if you have the same denominator, you want to add or subtract the numerators and then reduce if possible. So this lesson is going to start out pretty easy. So number one, we have exactly the same denominator. So you keep the denominator. Then you add or subtract the numerators if you can. They still have to be like terms. This is 9x. Can you reduce 9 and 5? No. So that's the answer. Pretty easy. Same denominator. We keep the denominator. Then we look at the numerator. Can I subtract that? Yes, that's a 6. Now, can I reduce 6 and 2? Yes, I can. 2 goes into 6 3 times. So we have 3 on top of xy. Really easy. Okay, getting a little bit harder here. Same denominator. Keep the denominator. We have a plus sign, so I need to collect like terms. 2x plus 4x is 6x. 5 plus 7 is 12. Can I reduce that? Well, I don't know, because at first I have to factor in order to reduce. Can I factor the numerator? Yes, they have a common factor of 6. Now we have things that are multiplied. Those are factors. Now I can reduce 3 goes into 6 2 times. So my answer is 2 times x plus 2 all divided by y. Got to do that factoring so we can reduce. Now those were 3 pretty easy problems. How are they going to get harder? Well, we have the same denominator, but we have subtraction. So I just want you to put up a little warning sign and say, I have to subtract all of that. So even though I have the same denominator, I have to be careful. So I'm going to keep the denominator, and I'm not going to try to subtract. I'm going to distribute my negative first. I'm not going to try to do that in my head. No. Distribute the minus to the numerator. Now, collect like terms. 4x minus 2x is 2x. Negative 1, negative 4 is negative 5. Can I factor that? No. Can I factor that? No. Are there any common factors? No. That's it. Distribute that minus sign. Same denominator. Just has a plus sign. That's nice. So I'm going to keep the denominator and collect like terms. Can I reduce? I don't know. I don't know until I can factor it. Can I factor 3x plus 3? Yes, I can take out a 3. Can I factor x squared minus 1? Yes, that's the difference of 2 squares. Do I have any common factors? Yes, I do, so those reduce to 1. So I have 3 on top of x minus 1. You see how we're reducing when we have those binomials? We have to factor. Number 6, got that minus sign. So again, I just know I need to distribute that. So I have the same denominator, so I'm going to keep it. Keep the first numerator, and now distribute my minus sign to that numerator. Keep the denominator. Collect like terms. Now can I reduce? Don't know. Got to see if I can factor, because this and this are not alike, so I can't just cross that out. They're not common factors. But I can factor the denominator as the difference of two squares. Now I have the same common factor of x plus 3, and so I can reduce that fraction. I know that was pretty fast. You might pause, rewind, go back to those problems. Keep the denominator, add or subtract across. If you have a negative sign, you've got to distribute. If you can reduce, well, you're going to have to factor it, and then cancel or divide out common factors. Let's do one more of these. We have the same denominator. We also have a minus sign. So I'm going to keep the denominator. I'm going to keep the numerators because I'm going to distribute that first. It only takes a second or two. It's worth it. Right? If I collect like terms, I'm going to get 4x squared minus 1. Now that certainly looks like nothing is the same. But I don't know I can reduce until I factor it. So the top is the difference of two squares. The bottom is a trinomial. So why don't you stop the video and try to factor this trinomial. Did you get it right? Check your signs. Now, do we have any common factors in the numerator and the denominator? Yes, I do. So I can divide those out, and I'm left with 2x minus 1 on top of x plus 6. Those are not the same factors. I cannot reduce. That's my answer. So if you have the same denominator, pretty easy. Just got to be careful with those minus signs. We're not going to have exactly the same denominator, but opposites. Remember how these are opposites? If I multiply this times negative 1, I get its opposite. So I'm going to use that fact to make these denominators the same. These are not the same. They are opposites. So I'm going to go through quite a few steps, and then we're going to kind of shorten it. So these are not the same. But you should know that 3 minus x is the same as negative 1 times x minus 3. Convince yourself of that. Negative 1 times x minus 3 is negative x plus 3, which is 3 minus x, just writing it in a different order. Now, still not the same denominator, because this is x minus 3 and this is negative 1 times x minus 3. Well, can do a little math magic. I can take that negative 1 and move it upstairs and make that a negative 2. If you remember, 1 over negative 3 is the same as negative 1 over positive 3. Is just as long as 1 is negative, then the whole fraction is negative. So that's why I can do that little trick and move the negative upstairs. Why did I do all of that? Because you have to have the same denominator in order to add and subtract. Now I keep the denominator. Now I have a 9 plus a negative 2, which is positive 7. And I'm done. Nothing else you can do about that. x minus 3, can't divide by 7, that's it. Okay, so I do not have the same denominator. So I have 8 over 3x minus 2 minus 7 over negative 1 times 3x minus 2. Remember, these are opposites, so I'm doing the same exact thing I did on number 8. Also, going to use that math magic. I'm going to move that negative 1 up here. So, I'm going to keep the denominator of 3x minus 2 because now I have the same. I have 8, but I have this minus times that minus. What does that become? A plus 7. So I have 15 over 3x minus 2. Again, cannot reduce that, no common factors. Are you kind of getting that trick, that little math magic I call? Good, because the next two are a little bit harder. Again, not the same, but opposite. So I have 6x plus 7 on top of 7x minus 4 plus, and I have a 2x minus 1 on top of negative 1 times 7x minus 4. So what am I going to do with this negative 1? I'm going to move it upstairs. But do you see how I put those parentheses? Because that negative has to distribute to both the 2x and the minus 1. So I'm going to keep my common denominator. I'm not skipping any steps. I'm going to distribute. Don't forget that negative times negative is positive. I'm going to keep my denominator, collect like terms. That looks like I'm done. But maybe you say, well, wait, I can factor the top. I can take out a 4. And you can, but do you have anything in common? No. So you could stop here, that's correct, or you could factor just to make sure that you could not reduce and stop there. Both answers are correct. Number 11, not the same denominator, but opposites. So we have minus, we have the 2x plus 1. That's going to be negative 1 times x squared minus 4. My math magic, going to move this upstairs. So keep the denominator. But now, hold on. How many minuses do I have here? I have that negative and that negative. Now up here I only had one negative and a positive. But a negative and a negative, what can I join those and make that? A big fat plus sign. So what I have now is x minus 7 plus 2x plus 1. The negative and the negative multiply together to get positive, and now I'm just distributing a positive 1, which does not change the signs. So keep the denominator, collect like terms. Am I done? I don't know. I bet I could factor. I can take out a 3. The denominator is the difference of two squares. Look at there. I've got a common factor of x minus 2. So I can reduce those. And that's my final answer. So go back and look. Remember what opposites are. The little math magic about moving the negative and all that distribution.